Hi, welcome to video on digital electronics. In this video, we'll see the implementation of Boolean expressions using TinkerCAD tool. Okay, these are the few prerequisites before we understand. Okay, let us straight away move on to implementation of this particular Boolean expression, which is the representation of this Y output using sum of product, and the same Y output is also represented using uh, product of sums. So let us try to implement these two circuits in TinkerCAD. So this is uh, a open source tool where you can able to implement all these simple logic gates. So let us move on to so now this is the TinkerCAD. You can create a login, and once you log in, you will reach this particular page. Now we can start creating. So now I want to create a circuit. So let me say circuit. So now let us see. I'll go to. Okay, now let me just create the circuit. It will take some time. So now this is the window where you're going to edit the things. So now let me just give some name for this. So let us give it as SOP and POS implementation. That is the name for it. And since we have to rig up the circuit diagram, let us take a breadboard. Let me place the breadboard here. So now this breadboard is required to just to place the ICs and do the. So let me take a voltage source which will give me the supply. This is the voltage source. You have the power supply. So let me take a power supply. So now the voltage is 5 volt. So I will use this wire. This is connected to the plus of it. So it's better to give the proper color for the wires also. This is red, and you can use the same wire for wherever plus is there. You just use. Now this is plus 5. So let me use uh, black wire to have the ground. This is ground here. Okay. Oh, sorry. This has also become ground. Sorry, black. Let me make that red, and this is fine. Now let me have another wire. So this is now. I'll just change that to black color. Fine. So now this should be black now. So this indicates that okay, whatever voltage that is there throughout the entire line, it is the same voltage. Even this entire row. And since the implementation is using these gates, which is NOT gate, AND gate, and OR gate, so we know that 7408 is so let us try to understand what are the gates we have. So let me say this is 7408. 7408. Okay, now this is an AND gate. This is 7404 is a NOT gate. This is 7408. This is 7432. So now this is a quad AND gate. So let me just, this is 7404 is a hex inverter. Can you see this is the X inverter? I'll place it here. So I'll place it such that, so this is a 14 pin IC. Can you see this is input 1, output 1, input 2, output 2, and this is input 3, output 3. This is ground. Similarly, this is output 4, input 4, output 5, input 5. This is output 6, input 6, and this is your VCC. So now this IC need to be given the supply. So let me connect this to this. So this, since it is the VCC term, I'll make this red, and okay, let me do that connection later. So let us have all the ICs now. 7404 is an inverter. Next I want to have a 7408. Let me have this AND gate here. I'm placing the AND gate. Let me have 7432. This is OR gate, again 2 input OR gate. So now these are the three ICs I placed. This is NOT gate, this is AND gate, this is OR gate. So now this is what you are supposed to implement. So this is, so I have to have a NOT gate to get the A bar, and from B I should get B bar, and this should be what? This should be connecting B bar and A bar. So this is A bar B bar, and this is A B bar. So this is A B bar, and its output is uh, they will become the input for your target. So now let me connect. Let me have sliding switches for. Let me say this as SW. Okay, this is a slide switch. Let me take this switch and place it here, and okay, let me place it at the extreme somewhere here. Let me place one more switch over here. Okay, now let me connect these two VCC. This is connected to VCC, and then let me connect this to again VCC. Let me just zoom it out. Sorry. Now let me connect this to ground. Let me make that color as black, and this is again ground. This is ground. Okay, sorry, this should be connected to, that should be going to this. So this is VCC, and if you treat it as A, so this will go from here to, okay, now we're going to have a wire. Sorry, I'll connect a wire from here to this is let me slightly deviate like this, and this will become A. Let me use a different color for this. So let me treat this as A. So this is A now. This is B. I'll connect this to somewhere here and let it go to this input, second input. So let me change this color to a different color, something like this, green. So this is A, this is B. So this is now A bar. So you can see one of the AND gate input, one of the AND gate. So I have connected A here, I'm getting A bar. So this is A connected A bar I'm getting. I'm connected B, B bar I'm getting. So this A bar, B bar will go to one of the AND gate, and other input is A, B bar. So what I have to connect is to this AND gate, I connect this A bar. You can see this is A bar, and I'll connect it to one of the input. How to know is that is input or not? If you just go here, can you see this is input 1A, this is input 1B, this is output 1. So this is what input 2A, this is input 2B, this is output 2, this is ground. So now let me change this color to a different color, maybe yellow. So this yellow indicates it is A bar. So this is now B bar. So what I'll do is I will take a wire from, sorry, take a wire from here. This is B bar. Will go to this pin, which is now B bar. So let me change this to a different color, maybe this. You see now this is A, this is B, this is A bar, and this is B bar. So A bar B bar output is this, that will become the input for your XOR gate. This is the let me just okay. Now I'll connect, because this is the output. Output of this AND gate will become one of the input for OR gate. You know, let me change this color to a different one, maybe a purple. Can you see now? This is the AND gate output going to one of the input, meaning we have actually done this. Uh, we have connected A bar, B bar, and this output is A bar, B bar output is going to the input of one of the OR gate, which is 7432. So now what I have to do, I have to connect A, B bar, and its output will go to another input of the OR gate. So it is now A, B bar. So A is here, A is here. What I'll do, I will connect, this is A, will become the input for, sorry, that should not go there. Let me delete that. So let me connect it. Okay, let me go somewhere here. This is going, this is going somewhere here. It should not be get connected. Now it has got connected. So let me delete that. So what I have to do is, let me connect this to, it should go to one of the AND gate output. I'm just placing it here. So let me make it slightly. I'll make this so that it is distinct. See now, this is what. Let me move this slightly here. Is this fine? This is actually A. A, let me change it to orange in color because this was A. Same A is going here, and other input is B bar, because anyhow I have the B bar here. This B bar is there. Let me take it from here only. One more input will go to, let me just delete this. So this is another input which is B bar will go to, this. Can you see? I'm just introducing. So this is actually B bar. Let me change that to the same color which is here. So is this B bar? This is B, green is B, this is B bar. Same B bar is going here. So this is the output of your AND gate, which is A B bar, which will go to one of the input of OR gate. This is going to second input of your OR gate. Let me change this to a different color, maybe pink. So now can you see, this is A bar B bar, this is A B bar. These two are the input for your OR gate, and this output is the final output. Let me connect LED to indicate that, to verify the output. So let me take a LED. So this is in LED. So I'll take this LED and then place it somewhere here. Maybe just put it down here. Now this is anode. This will go to, pin number 3. This will go to pin number 3. Can you see this is connected there? So now this is the output going to this LED, and the cathode I'll connect a resistor of around 220 ohm. is uh, so I'll take a resistor and place it between ground and cathode. So let me make the resistance as 220 ohms. 220 ohm is the resistance. Fine. I have made the connection. Just a minute. Okay, this is a connection made. So, but let me connect that VCC and ground to all the things, all the ICs. So let me take red, connect pin number 14 to VCC, pin number 14 to VCC, pin number 7 should be uh, grounded with a black wire. That's the standard colors. And then again another black is connected to ground, that is pin number 7. This pin number 7 is also connected to ground. So what we have now, we have an inverter IC, we have an AND gate IC, we have a OR gate IC. We have done these connections as per the uh, diagram what I have. So this is as per the circuit diagram what I have. So first we inverted A and B, we got as A bar and B bar. Then we are ANDing 2, and then the output of AND gate is given to this. So now let us verify this output. So what does the output says? So you can see uh, when it is as per the truth table, whatever is if it is 0 0, output should be LED should glow. When it is 0 1, output should be 0. When it is 1 0, output should be on. So here it is off, here the LED should be off. Again the LED should be off here, so here it is on. So now how do you give this 0 and 1? 0 is like, okay, giving 0 volt. 1 is like giving 5 volt. So this sliding switch has got 3 terminals. This has got one terminal, two terminal, third terminal. One of the terminal is grounded, the other terminal is connected to VCC. When this sliding switch moves towards VCC, you'll get 5 volts here. When the same condition goes to this side 0, it will be 0 volt. So this line will be 0 volt or 5 volt. If it is 0 volt, it is 0. If it is 5 volt, it is 1. So that's how we are applying the corresponding 0 and 1 for the corresponding input, and we'll see whether the LED glows or whether it is off. So let me go back here. So we know that when it is 0 0, the LED should be on. So what I'll do, I'll go to the TinkerCAD again. Now uh, let me set this voltage. Voltage is already 5. So now let me run. See, now I'm applying 5 volt. Since the input is 0, this is okay. Let me stop this and name the what is this? This is actually B. This is A. This is A, no? Oh, sorry. Okay, let me just take out this. This is now labeled as, this is A, and this is B. Otherwise you'll be get confused, okay, which is what. So this is B. So since now A is 0, B is 0, let me simulate. So can you see this B is 0, A is 0, this is glowing, this is glowing. So if you want to see much more brighter one, what you can do is you can slightly reduce the resistance to 100 ohm. So this is 220 ohm, let me reduce it to 100 ohm. You can see it is much more brighter. So now let me run it. You can see it is much more brighter, but it says that, okay, this indicates that it's having a large current. Let me go back, because maximum current that is allowed is 20 milliampere. It's drawing more than that, so that's why it is showing an error. So let us go back and make it as maybe 150 ohm. So this 150 ohm will be enough. Okay, will be fine. You see there is no danger now. So now you can see this is uh, 0, 0, output is 1. I'll make this B as 1. When B is 1, A is 0. Now when I slide it to this point, it is actually 1. So this is 1, 0. So 1, 0, output is 0. You see this B is 1, A is 0, this is off. So what I'll do, I'll just try to make this A1, B0. A should be 1. So now A, let me make it 1 and let me make B as 0. The moment I make B equal to 0, the output is high. This is 1. If you make both of them 1, 1, both of them 1, 1, output is 0. So that's what you're seeing here. You can see when both are 1, 1, when both are 1, 1, this is 0. So what we are trying to do here is, so we want to uh, realize this Boolean expression of this using gates. So we have used a NOT gate, an AND gate, and an OR gate. So this is a two input AND gate, two input OR gate, and a NOT gate. So these are the very basic gates which will be available in this TinkerCAD. So this plus and ground are essential so that you can tap the voltages which is 5 volt and ground very effectively. You can see this color will make sure that you're connecting. This is now a bar. This is, that's why you have different colored wires, so that while doing the connection, if you use distinct colors, then there will be no confusion. So maybe let me change this color also, because this is repeating. Maybe you can change these to a different color. So I can change these to unused cover and unused color, which is something brown here. Correct. So this is how you can easily rig up the circuit diagram and then verify the Boolean expression. Similarly, you can try this. Connect the two OR gates. The input are coming from, one is from A, other is from B bar, and this is from A bar and this is B bar, and you give the output of OR gate to two inputs of the AND gate, connecting. So while connecting this LED, so what we are doing is we are connecting the anode. The output is connected to anode, the cathode is connected to ground through a resistor of 220 ohms. So this is an LED. So when it is high, this glows. When it is low, this is off. This is how you can what comfortably conduct experiment using TinkerCAD. This is an open source tool. Anybody can download, or anybody can. This is an online thing. So of course, even it's available. You can have an app in your mobile. You can able to rig up all the circuits, simple circuits using this TinkerCAD. Thank you.